Very good morning to all. Again, welcome back to my course, Digital System Learning with Tinkercad Simulation. So, I am Dr. Syed Nagina Parvin, Associate Professor in SR University. In the last class, we have discussed about the universal gates. So, in universal gates, basic introduction. So, we have two types of universal gates. One is NAND gate and NOR gate. Then we have given I have given a introduction about the universal gates, why it is so called as the universal gate. So any type of the gate we can use, we can design using these NAND gate and NOR gates. So that's why it is called it as a universal. And in the last class, discussed about the NOT gate using the NAND gate, as well as the NOT gate using the NOR gate. In today's class, we will learn about remaining basic circuits. So basic circuits, OR gate using the NAND gate, as well as AND gate using the NAND gate, and we have two more, OR gate using the NOR gate, and OR gate and AND gate using the NOR gates. Now let us have a brief overview about the universal gates. So based on flexibility and cost, we are moving towards these universal gates. So truth table for NAND gate and NOR gate. So NAND gate, if any one input is 0, the output is definite 1. In terms of NOR gate, if any at least one input is 1, then definite output is 0, logic 0. Remaining all conditions, the output is high. Now we have NAND gate, NOT gate using the NAND gate. So NOT gate using the NAND gate. So how we have taken a designed a NOT gate using NAND gate by short circuiting two inputs and giving to single input. So we got the NAND gate. Now this is a NAND gate, will act as a NOT gate. So NOT A is equals to A NAND A. Right. Similarly, we have designed using the NOT gate using the NOR gate. So same, the short circuiting two inputs of the NOR gate and giving to single input. Then NOT A output expression is A NOR A. Now the next, similarly, this is our Tinkercad circuit we have designed in the last class. That is, whenever two inputs are on, the definite output is 0. If it is off, the first circuit is NAND gate, that is 7400. Second gate is 7402, that is a NAND gate, NOR gate, right? So when the output input is off, the output is in on condition, right? So same, we used to design using the OR gate by using the Tinkercad simulation. So let us take one new slide. Now OR using a NAND. Now OR using the NAND gate, right? So first, logic expression for NAND gate. So there we have to consider the OR circuit, right? So first let us consider OR using NAND gate. The same circuit we will design through Tinkercad simulation. So we have first OR gate. How many inputs for OR gate? OR, this is a OR gate. Two inputs we have, A and B is a two input. The OR gate output expression is A plus B. Now let us consider NAND gate. The NAND gate also contains how many inputs? Two inputs we have. So these two inputs, NAND gate, AB. Output expression for this NAND gate is Y is equals to AB whole bar, right? Now we have to use NAND gate to get an OR gate, right? Now same NAND gate output expression, that is truth table for NAND gate I am considering 0 0 0 1 1 0 1. The NAND gate is 1 1 1 and 0, right? So if you are considering the OR gate output expression is running the OR gate output expression is A plus B. So it is 1 1 1. So this is output expression. See, we have, this is 1110 and this is 0111. Alright. Let us consider Now this is OR gate expression. So let us consider this. If I use to complement this output expression, that is NAND gate OR gate output expression, then if you apply the using the De Morgan's theorem, so whenever I am using a complement, then A becomes A bar and dot becomes plus, plus becomes dot, right? So first implement this output expression inside, right? So if I use the output expression inside, I will get A bar, then dot becomes plus, B becomes B bar, hold on, right? If I again apply the complement of this expression, then I will get, so A complement double complement plus becomes dot, B becomes B complement, right? So there I will get A bar whole bar is A, B bar whole bar is B, right? So similarly, if I consider, so let us take one more slide, one more slide. So what is output expression for OR gate? Output expression for OR gate is A plus B, right? So if I apply complement on both sides, then I will get Y bar is equals to A plus B whole bar. Then apply this, so you will get A bar. So plus becomes dot, B becomes B bar, right? So this is Y bar. If I apply double complement, we know one property that A bar complement double complement is A, right? So similarly, I am applying one more complement here. Again apply complement. Why? Because if I apply the complement A plus B to double complement of this expression, then I will get A plus B, same as my OR gate output expression, right? So same property I am applying here. A bar whole bar, right? So if I again apply the complement, then I will get A double bar whole bar, that is A dot becomes plus B complement double complement is B bar, right? Now this is the expression for the NAND gate, right? But in the NAND gate we have y is equals to AB whole bar. But here in this case I have complement of A bar as well as complement of the B bar, right? It means if I draw the circuit diagram, so input A, so there I will get a A bar. Again input B, if I apply the NOT gate, then I will get the B bar, right? Now what is these two? These two is a product, that is AND gate, that is here I will get A bar B bar, right? And NOT gate again I have, so let us apply one more NOT gate, then I have A bar B bar double bar, so that is equals to A plus B. That is my OR gate output expression, OR gate output expression, right? So what I need to do, I have to consider first NOT gate, then NOT gate for two inputs connected to AND gate. So here if you look at over this, so here I have AND gate plus NOT gate. What is AND plus NOT? That is definitely NAND gate, right? So let us consider one more new slide, right? So first, why? So I know how to convert not using the NAND gate, right? So by connecting two inputs of the NAND gate to a single input, then it will act as a NOT gate, right? In the same way, so here my circuit diagram is A naught, B naught, two inputs are with a NOT gate, and in the last slide I have explained you about AND plus NOT. So in last this slide I have already told you AND plus NOT is NAND, right? In the same way, so here I got a NAND gate, right? So here it is the circuit. Here I have a basic gate also. This NOT gate is a basic gate, right? So one NOT gate I have, that is a basic gate, and universal gate I have. But what I need to make? I need to make the entire circuit into the universal gate, right? So entire design should be based on either the NAND gate or NOT gate, right? So here I have a NOT gate. So same NOT gate. So I am considering one NAND gate to connect to provide A bar, and one more NAND gate. I'm short circuit to single input. I'm giving to single input, that is B. So whenever I have short circuited the two inputs of the NAND gate, then it will be act as a no, not gate, right? So those two I'm connecting again back to one more NAND gate. So this is a NAND gate, right? So totally how many NAND gates I require here? If you consider this circuit, or if you are going through this circuit, so here I have first NOT gate, second NOT gate, and third NOT gate, right? So how many NOT gate I require? Three NOT gates and one AND gate, right? So total how many gates I require? I require total of 4 gates. See, only basic gates, right? So I required, if I take a NOT gate, so NOT gate IC, so NOT gate IC contains six NOT gates. In the 6 NOT gates, I am utilizing only 3. Okay, so if I utilize 3, if I have utilized 3 NOT gates, remaining 3 NOT gates are in unutilized conditions, unutilized. Okay, so there we have a space issue. Then I have to use one AND gate IC, one AND gate IC. Total how many ICs we require? I require 2 ICs, one NOT gate IC and one AND gate IC. Right? See the complexity. But here in this case, see, in the this is the designing, so I have only NAND gates, right? So total how many NAND gates I require? One NAND gate, second NAND gate, and third NAND gate. Okay, so I require 3 NAND gates. That is how many ICs I require? Only one IC I require. In the last place, in the last case I have required 2 ICs, right? But here in this case I require only one IC, right? So this is, so if I use, so space utilization is reduced, as well as so cost also reduced. Space utilization reduced, so therefore space utilization, that is complexity, also reduced. Complexity reduced, space utilization is reduced, um, as well as cost also reduced, right? This is the advantage of using the universal gate, designing the universal gate using basic gates using the universal gate, right? So this is a final circuit we have to draw using the Tinkercad. So using the Tinkercad, first we have to use 3 NAND gates, one NAND gate for giving connecting to the A bar, second NAND gate to getting the B bar, and third NAND gate to get the overall output expression, that is A plus B. This is how we have to, right? This is how we have to use connect these IC NAND gate. I require only 3 NAND gates. Okay, so let us remember first, this is my switch, right? So in this switch I required 2 inputs. This is 1A and this is 2A. So 1B and 2B is my inputs, right? So first I have to connect the IC NAND gate IC, NAND gate IC. So 7th pin is ground, 14th pin, that is VCC. So first input, second input, this is 1A, 1B. This is our output 1, output 1. 2A, 2B, this is output 2. Alright. So here I have also, so input 1A, 1B, right? Let us see with the IC. So this is a previous circuit, not yet using the NAND gates. Right, so here I need to clear one more new circuit I am taking. So in the new circuit, first let us begin with the basic breadboard. So I am taking a breadboard. So here I am using a large breadboard. Then power supply I need, so power supply, coin cell I am providing. So this is a coin cell, Connect this positive terminal. Change the color of this positive terminal to the red. Then connecting it to negative terminal. Negative. Change the color as well with a black color. Then I have required this resistor and one LED to check the output. So LED negative terminal has to be connected to black. LED negative terminal has to connected to black. Then I required one IC, that is NAND gate IC. NAND gate IC 7400. Right. So here I am connecting somewhere here. So this is 1A, 1B, output 1, 2A, 2B, output 2. So here in the output 3, 3A, 3B. So this is 3A, 3B, output 3, output 3. This is 4A, 4B, output 4. So first short circuit, use this short circuit, right? So here output is available. Connect this first input, connect this first input to either 1A or 1B, right? So this is output available. So this output is first output. Here what is output available? That is A bar, right? Again short circuit these two or these two. So let us consider shorting these two, 4A 4B short circuit. Okay, now connect this 2B to either 4A or 4B. Okay, so now what is output available? Here I have one output available, that is B bar. This is A bar and this is B bar, right? Now what I have to give? Connect. So let us consider this is my output 1 and this is my output 4. Okay, now take one more NAND gate, that is third NAND gate, and connect output as first input and output 4. Okay, so here I am taking one more input. Okay, 2A 2B I am taking, right? So connect these output, connect this output. Okay, so connect this output to first input 2A, output connect to a output 1 to 2A, and connect this output 4 to 2B, right? So connect this output 4 to 2B. 2B. Okay, now this is my overall output which is available. Now I am connecting these to one resistor, thereby I am connecting to one LED. Correct. So this is my overall output. So here I have to connect it to one LED. So this is a general view of the circuit. This is a NAND gate IC 7400. Right. So three outputs I have to use. So those three outputs using this, right? So this is the same how we will going back to our circuit. So NAND gate. So NAND gate first I need to connect a switch, SPST switch. So take a switch. So for switch how many inputs are there? Two inputs. Connect 1A to VCC. Change the color. Again connect 2A to VCC. Right. So where is my input is available? My input is available at 1B as well as 2B. Okay, now firstly what I need to do is first short circuiting. Okay, so first I'm using, so here I have clearly explained 1A 1B has to be short circuited and 1B has to given to this 1A or 1B, right? So first short circuit these two. So I'm short circuiting 1A and 1B. So let us change the color for input is green color. Okay, so where my input is available at 1B, my input is available. Now connect this input to either 1A or 1B. Okay, so let us consider it is a 1A. Right, now my output is available at uh, output 1. So what is my output is available at output 1? That is A bar. Right. So A bar is first output, that is A bar, first output of the first NAND gate. Okay. Now again I am using the 4B and 4A. Now again short circuit 4A and 4B. So for make a differencing. I'm using a different colors for different inputs. Okay, now this is a 2b. 2b is my input, second input. Whether I can connect it with a 4a or I can connect it with a 4b. So let us consider I'm connecting at the 4b, right? So meanwhile, don't forget to connecting the VCC as well as the ground. These are very important. Without these we cannot get an output. So ground black color and VCC, that is obviously it is a red color. Okay, now what is the output available at output 4? Output 4 is B bar, output 1 that is a bar. Alright, now I'm using what I'm using 2a, 2b and 2 is my next last NAND gate. Okay, now connect this output 1 to 2a. So let us change the color as a purple color. That is a first input to the third NAND gate. And where is my second input available? At output 4, my second input is available. Okay, so here from here to I'm giving as second input, that is 2p, right? So this is my A bar, that is available at 2a. At 2b, B bar is available, right? The overall output is available at output 2, right? Now where I need to connect this output to? I need to connect this output to this output 2 to resistor 1 terminal, and second terminal has to be connected to the anode and cathode has to be connected to the ground. Alright, so cathode has to be connected to the ground. So cathode already connected and one terminal is resistor terminal. Now this terminal I am connecting to resistor. So output is I am giving as a brown color. Okay, so yellow color I have indicated with to get the A bar. Green color I have indicated to get the B bar. Alright, so this purple color I have used to connect to output of, that is B bar as well as A bar. Right, and brown color I have indicated to get the overall output of the system. Right, so what is the OR gate operation? If I taking one more slide, so let us explain what is the OR gate operation. The OR gate truth table is OR gate have two inputs. So OR gate is A plus B, right? 0 0 0 1 1 0 1. So OR gate operation is at least one input is high, then definite output is high. So 0 1 1 1, right? So for 0 0 condition the output should be 0. For 0 1 it is 1. For 1 0 it is 1. For 1 1 it should be 1, right? It means if both are 0 0 0. Okay, so let us start a simulation. So here I am changing the name as, so this is how I have changed the name as OR gate using NAND gate as well as NOR gate, right? So NOR gate as well as NAND gate. Okay, so let us start a simulation. So this simulation I have started. For 0 0, what should be our output? That is 0. For 0 1, the LED should be on. It is obviously on. For 1 0, it should be on. It is on. For 1 1, it should be on condition. Hence it is proved. Now going towards the schematic view. So this is a schematic view. See. So first, how many NAND gates we have used? First NAND gate, second NAND gate, and fourth NAND gate. Okay. So this, according to whatever I have given here in the PPT, whatever I have shown, the same it will visible in terms of a schematic view. So this is a schematic view of the circuit. So resistor output, overall output, where it is available? It is available at overall output. So this is a second terminal. This is a resistor. Second terminal of the resistor has to connect it to output 2. So output 2 is the overall output. So output 1, that is a bar, and output 4, that is a B bar. A bar and B bar, it is short circuited connection, short circuited connection. Here you can see the short circuit connection. So it is a short circuit. So this is a short circuit. Okay, so here also short circuit off to get the B bar. Then A bar B bar connection given to the resistor, output resistor, then LED. Second terminal is connected to the ground terminal. Right, so this is our battery which produces the supply. Alright, so if you are going towards the component what we have used, that is a point cell resistor, LED, quad NAND gate, that is only one IC is required, SPST switch, right? So this is how we have to um, connect the, we have to convert the NAND gate as a OR gate, right? So thank you so much for learning this video. In the next class, I will explain about NAND gate using AND gate using the NAND gate, right? So that we will discuss in the next class. Thank you for learning this video. Thank you so much.